Hi guys, we are looking at text and test 5, section 8.2, page 240, 242. This is composition of functions, and really we're just going to dive straight into some examples to see what composition of functions means. Question 1 gives us two functions, f of x, which is x squared plus 1, and g of x, which is 2x plus 1. So if you're asked for f of 3, we already know how to do that. That's 3 squared plus 1. That's 9 plus 1 is 10. G of f of x plus 3 means evaluate f of 3 and then plug it into g. So we already evaluated f of 3. There it is, 10. So plug that in. You get twice 10 minus 1. Okay, so that's 19. So that's composition of functions. When you have two functions, you put them together. You do this one first, and then it's g of f of x. You'll sometimes see g of f of x like this. So where you put the f of x in brackets in the same way as you'd normally put the x in brackets. Or you'll sometimes see g of f of x like that as well. Okay, but this is probably the most common notation, g of f of x. G of 3 is 2 times 3 is 6, take away 1 is 5, whereas f of g of 3 means plug a 5 in here. So it's going to be 5 squared plus 1, which is 26. F squared of 3 is f of 3. Okay, so f of 3 is, we've seen already, 10. So plug that back in again. Okay, so that's 10. So it's saying f of 10, and that is 10 squared plus 1, which is 101. G squared of 3, maybe try that one yourself. Pause the video and I'll do it now. Okay, g squared of 3 is going to be, plug in g of 3, which we have already up here. That's 5. So it's g of 3, which is g of 5. And g of 5 is twice 5 minus 1, which is 9. G of f of minus 4, plug a minus 4 in here, you're going to get, well, let's do that. G of minus 4 squared plus 1, which is g of 16 plus 1 is 17. And then you come back up here, plug 17 into this, twice 17 minus 1. That's 34 minus 1 is 33. The last one, f of g of a half, well, g of 1/2, it's f of twice a half minus 1, which is f of 1 minus 1 is 0. Then you come back up here, plug a 0 in up here, and you get 0 squared plus 1. So you get 1 out of that. Okay, so that's the notation. That's more or less what this whole exercise is about, is knowing to use that notation properly or what it means. Question 5 asks, if f of x is 3x squared and g of x is 2x plus 1, find f of g of x. Okay, so rather than finding a number here, we're going to find a function, but it's the same idea. Plug g of x into f of x. So we're going to get 3 times x squared, but instead of x, we're putting in 2x plus 1. And that's going to be 3 times square the first, 4x squared, square the second, 1, twice the product is 4x. So you get yourself 12x squared plus 12x plus 3. Right, 12x squared plus 12x plus 3. And the second part of that question says, hence solve the equation f of g of a equals g of 1. Well, f of g we've already got of a, so that's going to be 12a squared plus 12a plus 3 equals, and g of 1, if you plug 1 in there, you get 2 times 1 plus 1, okay, which is 3. You move that over, it's going to cancel with this 3 here. So we're going to get ourselves 12a squared plus 12a equals 0. Okay, when you bring that over, dividing through by 12, you get a squared plus a equals 0. Factorizing, a times a plus 1 equals 0. So either a is 0 or a a is -1 will be our solution to these bits. Okay, so those are the two possible answers. Question 5 doesn't say anything about the values that a is allowed to take, so we'll offer both of those answers. Question 11, if f of x is 2x plus 3, find f squared of x. Okay, so that means plug 2x plus 3 back into itself. So twice x plus 3, but instead of x, you're saying 2x plus 3. And that's going to be 4x plus 6 plus 3, or 4x plus 9. F cubed of x means plug f squared back into f of x again. So that's going to be twice x plus 3. But this time you're plugging in 4x plus 9. So that's going to give us 8x plus 18 plus 3. So that's 8x plus 21. And if you want to find f of 4 of x, you plug this back in again. You get twice x plus 3 from up here, but you're plugging in 8x plus 1, and that's going to be 16x plus 8x plus 21, excuse me, plus 42 plus 3. So that's 16x plus 45. Okay, and then the question says, well, for n of x, what do you get? So if you look at the pattern, this is f of 1 of x, if you like, and don't mix that up with prime for differentiating. F of 1, just make sure it's a 1. You go 2x, 4x, 8x, 16x. You can probably guess that you're doubling with each step here. So that's 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So you're going to get 2 to the power of n multiplied by x. Plus, what are you getting here? 3, 9, 21, 45. Okay, what's happening there? Well, you're adding 6, then you're adding 12, then you're adding, excuse me, is that 24? Okay, so that's increasing by 6, 12, 24. It's got a common second difference of, no, it doesn't, 6 and 12. It has a third difference of 6 by the looks of things. So is that going to be an exponential function, actually? So I think we can't use that. What we should look at instead is the fact that this is going 2 by 3, okay, 6. And then now, is there a better way to do this pattern? Yeah, you'll get 3 cropping up over and over because you keep multiplying by 3 here. So I'm actually going to go back to this set of numbers here and take 3 as a factor. So you get 3 times 1, 3, 7, and 6, 15. Okay, and it's probably tricky to spot, but those are all 1 less than the square numbers. This one being accepted. So that's 4, 8, sorry, not the square numbers, the cube numbers. 2 to the power of 0, 2 to the power of, excuse me, 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. There we go. Okay, -1 in each case. Now, sorry, that's messy enough, but anyway, 3 times 2 to the power of n, and then take away 1. Ask me about that tomorrow in class if you're stuck. Actually, I don't want to spend a lot of time on that in the video. Question 12, functions f and g are defined by f of x equals x squared plus 1, g of x equals 1 minus 2x. Show that g of f of x is not equal to f of g of x. Okay, so f of g of x is when you say, well, f of x is x squared plus 1, and plug in 1 minus 2x, whereas g of f of x is where you say g is 1 minus 2x. and plug in for x squared plus 1. So what you get here, square the first, square the second, twice the product gives me 1 plus 4x squared minus 4x, and then plus 1. Whereas this gives me 1 minus twice x squared minus 2. Okay, so up here, I'm getting 4x squared minus 4x plus 2, and down here, I'm getting minus 2x squared uh, minus 1. Okay, so these are not equal to each other because the square terms don't match up, the linear terms don't match up, there's no linear term here, and the constants don't match up. What they are showing here, so you can say, therefore, g of f of x is not the same as f of g of x. You might remember this term, they are not commutative. Okay, so commutative, things that can be rearranged, like 3 multiplied by 4 is the same as 4 times 3, that's commutative. But 3 divided by 4 is not the same as 4 divided by 3, so that is not commutative. Same thing here, composition of functions, generally speaking, is not commutative. Okay, now, please, I'd like you to do questions 2 and questions 3, and we'll take up with this tomorrow. Thank you.